Hello and welcome to this Innova Systems Customer Day presentation. My name's Adam Rose and what we're having a look at in this session is effective plastic part design. So it's some of the tools you can use within SolidWorks to kind of streamline the design process for those parts that are perhaps injection molded within SolidWorks. The first thing we're going to have a look at is some of the features that you can use to create some of those kind of complex items you often see within injection molded parts, things like mounting bosses, ribs. We'll use the indent feature as well to create some of the areas within the model, as well as possibly the save bodies tool. So first things first, I'm actually going to switch over into SolidWorks, and this is the model I'm working from. So I've just got one half of what will become the case for an electronic screwdriver, and we're going to go through the process of creating some of those internal features, as well as also bringing in the other half and taking the modeling a bit further with a bit of SolidWorks plastics eventually. So first thing I want to do, I'm going to bring in an existing button which has already been created. I'm putting in a button down the center of this device which will slide one way or the other depending on which way we want the motor to run within this electronic screwdriver. So it will reverse the direction of the motor by flipping it one way or the other. To bring this item into SolidWorks, I've actually already got it saved within the design library. Now, if you've not used the design library before, you can actually go into here and you can bring in existing features that you might have already created and drop them into your model. You'll see I've already created a folder in here and I've saved this item, which is simply just a little extrude feature. But to save you from creating this feature over and over again, I can actually drop this into a number of models and reference to it quite easily. So I'll just pop this into my graphics area just by dragging and dropping. Now the first thing it looks for is a placement plane. And in my model, I'm going to use the placement plane which runs down the center of the design. That's the right plane. And then it looks for similar references that it had in the original model. So it's looking for a sketch point at the moment. I'm going to use the origin within my design, and that brings it to this position. And then we got these locating dimensions which I specified, so I can just type those in to actually pop the model where I want it to go. So with it in the right place, we then just hit the tick, and that inserts the button for us. Having inserted this button into the model, what I'm then going to do is use the indent feature to offset from the outer faces of this feature. I'm going to allow the housing to actually control the position of this object, so it'll be able to slide in and out without wobbling around too much. If you've not used the indent feature before, you can find it from the insert menu under features, middle of the menu there. By selecting the target body in our design, that's our overall casing, and then in the tool body regions, we select the area of our button here. At the moment, we don't get a preview, but if I set this T1 box, a thickness box, to a smaller value, you can see that then it will give us an offset from those faces of that section of the model. We can then also put in a spacing, which is quite useful, which allows us to space out from the exterior faces of this object, giving us a slight amount of tolerance around the shape. Once we're happy with that shape, we can then simply hit the tick, and that will indent into the casing the shape of our button. Now this item here I can actually hide out of the way now, and you'll then see that's the shape I've created within my case. Now obviously I don't want it to be a closed face on the end here, so what I'm going to do is just a very quick sketch just on the end of this object just to remove that face. Okay, with this item dimensioned at the right size, I'm then going to cut this straight down into my model, and I'll choose the extrude cut tool and just cut down by 6.5. There we go, and that gives us that shape cut into the model. Next thing I want to insert are the ribs that will control the position of the motor within this design. The rib I'm going to insert will be created on this plane that I've already made within the model. I'm just going to draw a very simple sketch on this plane. And when you're drawing a design like this, the best way to approach it is by using the section view tool. If we section into this design, we can then see straight through it, which allows us to draw the rib a lot easier. The shape of this item would just simply be a circular cut out into the design with just a straight line going across the middle. Now, if you've never used the rib tool before, it's quite straightforward. You don't actually have to make sure that these lines here intersect with the edges of the model. You can actually just leave them the way they are. Now, with this shape drawn out, I can then just put in some very simple dimensions to control the position. So with these two objects, one at 5.4, one at 12, we can then insert the rib. I'll take myself out of the section view and I'll select the sketch and use the rib tool. Now, we've created this item parallel to the sketch plane, but you can also create ribs normal to the sketch plane, a bit like your normal extrusion features. We can apply the thickness we want to insert here, so I'm going to apply a 1 mil thickness to that object, and then we can also apply a certain degree of draft to the outside faces, so I'll put on 2 degrees of draft there. Okay, once we're happy with that, we then need to select the body that we're going to create the rib into. If you've got multiple bodies in your design, you've got to bear in mind that obviously there is an arrow here which needs to point towards our design. So if I flip material side, this tick box just here, that flips the arrow towards the model. There we go. Now, in order to create a number of other ribs within this design, I'm going to use a linear pattern tool. Linear pattern can be a tricky one to use if you haven't got any straight edges which are obvious to select within your model. I want the next rib to go about here. So what I'm going to do is I'm going to first of all select the feature I want to create the pattern from. And then what I'll do, I'll select it in this direction box, the dimension I'm going to use as the direction. And you'll see that actually it positions itself parallel to the position of that dimension. And then we can obviously put in the figures we want. So having got that in the right position, I'm then also going to create one in the second direction. I'm going to use this small straight edge here to do that. You'll notice that when it does it, it copies both items in direction 1. In order to avoid that, we need to tick this tick box just here, pattern seed only. Okay, and then we only get one copy from the seed. By spacing this item at a position of 25, I'm then going to alter the size of the object. You'll see that at the moment, it's way too big for the position of the model. In order to get round this issue, I'm going to go down to where it says instances to vary. And in this box down here, we can vary some of the instances in our pattern. In the direction 2 increment box, we can then select the 2 dimensions we want to vary, that being the 5.4 and the 12. And then what I'm going to do is I'm going to select this little dot here shown in purple, and we can modify instance. We can then type in some alternative values in these boxes, one being 2, and the second bringing this size down here to 4. If we then select within our feature scope the body we want the item to apply to and hit the tick, it should then create those patterned items. So you can see you can get quite a lot of variety between your patterned elements by using the instances to vary option. Having inserted these features within the model, I'm then going to bring in the mirror for the other side of our design. Okay, and you can see the second half of our model. And I'm also going to drag down once more to reveal a 3D sketch which has already been inserted. These have been put into the design earlier on, so that then I can just bring them in when I was ready. I'm going to hide this half of my model. And you'll see that the position of this sketch point is placed on this face here. Now that's going to decide the placement for the next feature I'm going to insert. The feature I'm inserting next, you'll find under Insert and Fastening Features. you'll see there's a number of features here which are specifically designed for injection molded models. I'm going to bring in the mounting boss tool and insert it onto my model. Normally when you're inserting this tool, you just simply select the face and click on mounting boss, and it gives you a preview of the item at that position. But if you want to be a bit more precise, you can put in a sketch point before you start, so that then you can select the mounting boss tool and it pops itself onto that sketch point. It's up to you which way you do it. You can always go in afterwards and edit the position of the item once it's already been inserted. Having got the item inserted in the correct location, I can then decide on its orientation by using a plane in my model. So I'm going to use the right plane in this second box on the left. And I'm also going to go down a little bit further and adjust some of the options. Now you'll see that we've got a number of options here about the different sizing for the elements for this mounting boss tool. We've got options for whether we want fins to be inserted as well. And then we've also got this favorites box. Now this is the particularly useful box that we can use for this tool. As you can imagine, to enter all of these values in over and over again for a number of mounting bosses can be quite tiresome. So what you can do to avoid this is you can use the favorites box to load and save different values that you've already inserted. And that's what I'm going to do in my particular example. So I can load a favorite in here, which allows me to select one from my machine. I've already got the item saved, so I'm just going to select it, click open, and then it will insert it within my model. Now, when it's brought the size down, it can actually fit and align itself in the correct orientation. We may need then to orientate the planes in the correct direction, so we can use the fins box just here and a sketch plane. I'll use the front plane in my design, and that aligns the planes up with the front plane. If you wanted to add your own favorites when you've entered these values, what you can do is just click the little plus. This will delete a favorite, or you can save and load different favorites from the box there. It just makes the process of inserting a mounting boss that bit easier. You'll see the mounting boss I'm inserting within this example is a hardware boss, and it is the head side of the boss. We could put in the thread, and that's what we'll do next. When I'm happy with that feature, I just simply hit the tick and it inserts the mounting boss at that position. If we rotate round the model, you see it's also created the cut on this side, and we've got all the fins inserted in one go. So it is doing quite a lot within the tool. What I'd like to do next is bring back the second half of my model. So I'll just go to the solid bodies folder and bring back that mirrored item. I'm going to insert a second mounting boss at this position, and that will be the thread side of the mounting boss. The best way to insert the mounting boss feature, if you've already got one on one side and you want to use it as a reference for the second, is to section your model. I find that is a lot easier than trying to go through the design and possibly make something transparent. It often works a lot better. So once you've got the design section down, what we can then do is simply select the area on the face we want the item to be inserted. I've just clicked on the face there. Click on the mounting boss tool again, and then we can simply align it once more with the plane in our model. So I'm going to align it with the right plane. We can then also use this box here to select a circular edge to define the placement of the mounting boss. And that will just be one of the circular edges on my existing item. So possibly this edge here. Okay, you see it's just cleared this box. I may just have to reselect that. Okay, there we go. So you'll see it's picked up on the fact it's a hardware boss. You'll see it's picked up on the fact that this is the thread boss. Lower down within the box, we can then define the height and the position. Again, I'm going to load something from the favorites rather than typing all these values in. So I'm going to click this button. Okay, having got my item inserted, I can then also select a mating face. This mating face that I'm going to use is the face on my model just here. Okay, you see all of a sudden, it does have a habit of doing that, but all of a sudden the preview will appear. In certain occasions, it can't quite do all the calculations to insert the item properly, As soon as you go ahead and select the right face or bring it round to the right orientation, you'll instantly get a preview. So it can take a minute or two to actually get that to come through. But just keep entering the settings and it should work fine. What I'm going to do next is select this box here to put in a slight clearance between the head and our original mounting boss. Once I'm happy with the shape, I'm simply going to hit the tick. There we go. So there's the two mounting bosses, one on one side of the design, one on the other. I'll take myself out of the section view now. At this point in my design process, having inserted the mounting bosses and having inserted some of the other features like the ribs and the indent tool, I'm then going to use one of the other fastening feature tools. That's the lip and groove tool. Again, another quite useful tool within the software. To insert it, we simply click on lip and groove. We then select one half of the model in one box. We select the other half of the design in the other box, and then we select a plane that will be normal to our lip and groove in the lower box. You'll see then it hides one side of your model, and then you can go through the design selecting the faces where the lip and groove will be placed. So that's this face just here. We can then, in this box below, select the edges on which it will be inserted. You'll see that tangent propagation does get turned on, so it does propagate around any tangent edges. So you may just have to select a small number of edges to get the item to go right the way around your design. When you're happy with that, you simply click on the next box in the lip selections, and you can rotate the model round and do the same thing on the other side. Selecting the face and then a number of edges to insert the lip and groove right round your design. Okay, you'll see it propagates right the way around there. When you're happy with that, we can then define the size of this item. You can either type the values in, or once again, you can load them from a favorites list. Now, occasionally when you're inserting the lip and groove, it will give you this warning. And it's not really an error, it's just something that SolidWorks wasn't able to do in this particular case. It tends to be something that you find quite often with organic models. It does struggle to extend the faces of your design round all the way around your model so that you can create the lip on one side of the design. So rather than failing, it just inserts those faces straight up normal to your model, a bit like an extrusion feature. So it's giving you this warning message just to make you aware of that fact. You can see if I hide this top section of my model that this face just here is not extended up from this one, i.e. there's a break. Now, what you might want to do in this particular model is go through the design and just check that you've got the right amount of draft right the way around your design when it inserts a face like that one. So what you can do is you can use the draft analysis tool to check that. It's quite a straightforward tool. You simply select the plane which you want the draft to be normal to. Put in the angle of draft you want to measure the model against, in this case 2 degrees, and then just make sure your arrow in the graphics area is pointing upwards. You'll see there within the design that you can see most of the faces have the required level of draft within your model. There's only a few that, like say, are shown in this yellow colour, which indicate that we might have to actually apply draft manually onto those faces. And that'll be a fairly easy and straightforward process to do by going to the features tool and using the draft tool from the toolbar. Okay, that's something I'll do later on in this design. One of the last features I want to insert within this model is a small cut which gives me the trigger section for this model. I'm going to drag a sketch in which I've already created from the design library and just locate it on a plane with the sketch point located on the origin. If I hit the tick, I can then use that sketch to cut through my model. I'll create an extruded cut and I'll do it so that it's up to next. Okay, that nicely cuts through my design. I'm quite happy with that in this model at the moment. So what I'm going to do is I'm going to take these two halves of the design and now I'm going to work on them separately in different part models. We can easily do that by right-clicking on this Solid Bodies folder and using the option to save bodies. The Save Bodies option gives us the option to save the resulting parts of our design. You see there's only two available because we've hidden the third one. That was that button. We can give them file names by just simply double-clicking. I'm going to call this one the right-hand case, and I'm going to save that in this folder here. Okay. And I'll call this one the left-hand case. We can also create an assembly which combines these two parts and sits them over the top of the origin within an assembly model. If we're happy though, we can hit the tick. Okay, it can take a minute or two just to run through. You imagine it's doing quite a lot of processes within SolidWorks, but when it's done, you'll find that you've got two models which represent the two halves of your design. Okay, by flipping ourselves back into this section of the model, what I'm going to do next is I'm going to use SolidWorks Plastics to do a bit of a mold flow simulation on this design. SolidWorks Plastics allows us to do some quite nice simulations within the software. We can easily work out things like an analysis of the mold flow, how long it's going to take to fill, and how easy the process will be within the software. We can pick out quite nice things like air traps within the design, or possibly weld lines, the points where the flow fronts come together. It's got quite a nice database of different polymers. I think the best thing to do is if we switch over, we'll have a look. So first things first, if you wanted to use SolidWorks Plastics, you have to open up the add-ins menu and you can access it from the menu just here. It is a purchasable add-in to SolidWorks, so it is something you buy in addition to the software. There are three levels to SolidWorks Plastics. You've got SolidWorks Plastics Standard, SolidWorks Plastics Professional, and SolidWorks Plastics Premium. And as a basic overview, the Standard gives you mold flow, Professional gives you the addition of the packing phase of the injection molding, and within SolidWorks Plastics Premium, you can have a look at the cooling phase of injection molding. Within the model I've got just here, I'm just going to save it very quickly, and then what I can do is you'll see the results figures will get populated just here. I can then create a mesh. Meshing is the first step when actually creating a simulation. Any kind of simulation in SolidWorks, we've got to mesh the model so that SolidWorks can work it out in smaller chunks. I'm doing a shell mesh in my design because within SolidWorks Plastics, it's best suited to thin-walled parts. What I'm going to do next is I'm going to switch through to the next screen. That allows me to actually set the settings for this shell mesh. We can set the triangle size to any size in the software. If I set it to 1.5 here and click mesh, we can get an idea of what the mesh will look like on the model. If the mesh is too refined, then the plastic simulation will take too long to solve. And if it's too coarse, then you won't get accurate results within your design. You can see the level I've got it at the moment. It's meshing the model quite nicely. It's probably a good place to start within the software. What I'll do next is just hit the next button. You can see it gives me a breakdown of the mesh itself. And then the final screen allows me to edit the mesh manually if I want to. I can do things like insert new nodes or delete some of the triangles I've already got inserted. If I hit the tick, that will then insert the mesh on my model. At this point, I can then insert the polymer on my design. There's a huge database of polymers available within SolidWorks. You'll see that you've got them categorized under different plastic types with a number of plastics available in each one. You can use a search tool to find the specific plastic you're looking for. In this particular example, what I'm going to do is use a polycarbonate in my model because I want it to be a fairly sturdy casing. So I'm going to use this one that's selected just here. You'll see that whenever you select any of the plastics, it does give you charts showing you the viscosity, things like the specific heat, the Poisson's ratio. You've got a number of graphs you can actually refer to. If the plastic you want isn't defined within the database, you can go to user-defined data bank and you can find it from there. You can also create new plastics in here, or you can download and upload them as well. At this point, I'll hit the tick. You'll see that when we define the settings for each one of these items, you can see a tick. The next item we have to insert is the injection location. If I open the settings, I can then set the location by simply selecting the place on the model I want it to go and clicking the button to place an injection location at that position. When you define these three simple items within the software, you can then run a very simple simulation to give you the mold flow and possibly the packing analysis. You can adjust the packing settings. At the moment they're set to auto, but you can do things like adjust how long it will be holding the pressure. And you can also adjust the fill settings as well if you want to play around with possibly the overall injection pressure limit and things like that. Rather than running this simulation right now, what I'm going to do is open up an example which has already been run through. In this design, if I flip over into the left-hand side, you'll see that what we've got here is plastics that have already been run through. You've already got some results. I can double click on these just to load the results up. The first graph we've got is the fill time. We can play an animation to see actually what that looks like on the model. You can view that in an isoline mode to give you a slightly different output. And if you want to, you can turn on the Plastics Advisor, which gives you a bit of information about the mold flow you've just run. There's a number of other graphs we can have a look at in here. We've got the pressure at the end of the fill, the cooling time, sink marks, which are particularly useful to have a look at. You can see them best on this side of the design. The particular ease of fill within this model. There's a number of graphs. Like I say, that's just some of the better ones. You can also have a look at weld lines, like I say, where you've got the mold flow fronts coming together. And you can have a look at air traps as well to see where you possibly might have to vent the design. So you can see in this particular model, I might want to consider adjusting the gate location. The packing analysis gives me nice graphs like the pressure at the end of packing, the shrinkage from the design, the residual stress within the model, and also shear stress at the end of the packing phase. So you can see quite easily within the software, you can get some quite useful results which can help to inform your design process. You can also use SolidWorks plastics to run more complicated studies. One of the ones I want to have a look at is runner balancing. This design represents the two halves of one injection molded part. You'll see that they are different sizes and different shapes. Within SolidWorks plastics, you can see that this model has already been meshed with a shell mesh. What I'd like to do is design the runner system for this particular model, and I can do that using the runner design option. I've got a sketch which represents the rough shape that I want the runner system to be. So I can just simply click on that and design the runner system by simply clicking on lines and defining the dimension that I want to apply there. So I'll put in 6 and 4. Click apply and it applies that onto my model. By selecting one half of the design, clicking apply, I can then apply a runner system on one side and the other side. I'll then bring that size down towards the model, and if it comes in the wrong way round, we can easily flip those dimensions. That's all well and good, but we may find if we were to actually run this simulation in the software that one half of our design would fill before the other half, which ultimately gives us problems in the injection molding process. What SolidWorks Plastics can do is balance the two halves of our runner system so that effectively the two halves of our design will fill at exactly the same time. And that's what I'll have a look at. You can see what I've got here is a model that already has the results applied to it. If we have a look at the runner balancing process that has already been run, we can have a look at the thickness distribution across the model. You can see if I tick that option on, you can see that the values that have been applied within this runner system are varying as they go through the runner channels. If I flip this around, you can see it's also different on the other side. Effectively, it means if we have a look at the flow results, you can see that the fill time plot within here, if you have a look at that, you can see that both halves of a design fill exactly the same time. This is quite a complicated process to do within a normal injection molding system. By using the runner design option within SolidWorks, we can cut down on a lot of experimental trials to actually work out that runner system. Obviously, what I've shown today is only a snapshot of what SolidWorks Plastics can do. There are quite a variety of options available within the software when using SolidWorks Plastics. If it is something you're particularly interested in, you can let us know. So hopefully that gives you a good idea of how you might use SolidWorks Plastics and some of the other tools within the software, for example, these fastening features, to actually create models for an injection molding process. Thanks very much for watching.